Okay, class, where we are now is to talk about the large intestines, which are also called the colon. It's about twice the diameter of the small intestines, you can see, and about 5 feet long. Its function primarily is to absorb most of the remaining water and indigestible food residues and store it until it's ready to be eliminated as feces. That's primarily its job. Okay. Its functions: it reclaims vitamins, water, and electrolytes are reclaimed. You put about 500 to 600 cc's, let's say, in here every day, and most is reclaimed. You eliminate about 100 to 150 out of here. And that's what basically happens with the laxatives, some of the laxatives, the osmotic laxatives, let's say like milk or magnesia. It disallows you from reabsorbing the water. Why? Because milk or magnesia is an osmotic laxative that increases the osmotic pressure in here that disallows the water from leaving. Major functions: propulsion of feces towards the anus. Since it's just a storage for residue, it's not really essential. Okay. So let's look at the unique features that we have. Okay, let's start first with the design, then I'll come to this right here. Okay, the large intestine or colon is going to start right after the ileocecal valve. This valve here is the last part of the small intestine. So what you have here, let's go right here. This area is called the cecum, that little pouch coming down here. Hanging off of that is the vermiform appendix. Remember that lymphatic structure. Coming up this way is the ascending colon coming up. This is your transverse colon. This is your descending colon. This right here starts your sigmoid colon, and after this starts the rectum, and that's the anus. Ascending colon, transverse colon, descending colon, sigmoid colon, rectum, and anus. Okay? Then we come back again. Let's talk about what I'll call the flexures. The flexures that you have in there. All right. You come up, ascending colon. Right here at this bend, this is called the hepatic flexure. Why? Because the liver would have been here. This is called the splenic flexure because the spleen. This is the sigmoid flexure, and this is the rectal flexure. Let's do it again. Hepatic flexure, splenic flexure, sigmoid flexure, rectal flexure. Okay. Now, the colon has these bands here, these 3 bands. There's one, you see. There's 2. There's one on the outside. But it'll be 3 bands of longitudinal smooth muscle in the muscularis. And what that does is that is shorter than the actual colon. So it kind of puckers the colon, shall we say, into these things called the haustrae. Pocket-like sacs caused by the tone of the Taenia coli. Okay. Then you have these fat pads hanging off called epiploic appendages. Okay. Okay. Let's go a little further with the large intestine. See what else we got there. Okay. We already did this. We already did that. Okay. Ascending colon, this part and this part are behind the peritoneum, retroperitoneal. This part here is hung by that mesentery. That mesentery. But this here is stuck behind the peritoneum. So here's that mesentery right there. 23. And you've seen that mesentery plenty. Well, I don't have it here anymore in that video. But anyway, that's the mesentery. Okay. And this mesentery is really called the mesocolon. This type of mesentery is called the mesocolon. And you remember that we had, let's see, here's that, let's see if I can find something there. And I don't know if I can. Okay, I'm going to close the small there. Let's see if I see something. No, I don't think I have. Let me see if I see that mesentery to show you that. Okay, here's the mesentery, but the one for the large intestine is called the mesocolon. The one for the large intestine, which would be, that's the stomach, that's the transverse mesocolon. See, that's the transverse colon right there. Let's blow it up. Here's your transverse colon right there. Go over a little bit. So here's that transverse colon, and here's the mesocolon right there. All right. So we go further. There we are, transverse colon right here. Transverse mesocolon right there. There's the great omentum right there. Okay. Transverse mesocolon again. Okay. So now we go to the rectum. So let's go to the rectum now. Okay, the rectum has these rectal valves, and they stop feces from being passed with gas. Otherwise, if you pass gas, you would also pass feces. So these three rectal valves, you only see one here on this drawing, but separate the gas from the feces. Then you got the anal canal down here, okay? And here you have these anal columns and anal sinuses between the columns. Anal columns and anal sinuses, okay? It's the last segment. Then you have an internal sphincter and an external. The internal sphincter is smooth muscle. The external sphincter is skeletal muscle. That means the internal sphincter, this is just like the, remember the urethra, external and internal, and things of that nature? Smooth muscles one. So continence, to hold continence, you voluntarily do not pass feces, defecate until you want to, because of this. This one opens because of the autonomic nervous system, parasympathetic. Okay. So we go here, mucosa of the large intestine, the mucosa is simple columnar epithelium. In the anal canal is stratified squamous, because that's opening to the outside. Abundant deep crypts and goblet. Extensive mucus eases passage of feces and protects the intestinal wall from irritating gases and acids. Low folds give anal columns and anal sinuses between the folds. The sinus exude mucus when you defecate to help it out. Exude mucus. So when you defecate, it comes down, that mucus mixes with it. The horizontal two-shaped pectinate line right there. Let's talk about that. Superior to this line, the mucosa is innervated by the visceral sensory fibers. Autonomic, other words. Autonomic, visceral sensory. And is relatively insensitive to discomfort, to pain. The area inferior to this is the somatic, just like on the skin. So you feel pain, hemorrhoids, scratches, whatever there. Superficial venous plexuses, that's the hemorrhoids. If they enlarge or dilate too much because of straining in the stool and other reasons, you could get hemorrhoids. And and if they protrude too much, they could burst as you strain, and then it would give a bloody stool, a bright red bloody stool. Here's something too. If you see blood in the stool, that's not good. But if it's bright red, you're in much better shape than if it's coffee ground dark. Bright red means it's closer down there. Coffee ground dark means it's up high, and it could suggest a cancer. That's why we do this test called the guaiac. I don't know if you're familiar with the guaiac. It's where you, at the doctor's office or at home, you take a little stool, put it on there, and then put a developer on to see if you have blood in the stool. If you do, then you have to be checked out. Because, you know, colon cancer is very prevalent. Bacterial Flora, about 10 million different types, enter from small intestine or anus, come up or down. And they do a lot of good stuff, as long as you keep them in check. You can read this. They do a lot of good stuff as long as you keep them in check. Most bacteria exist peacefully with their host, but an elegant system keeps them from breaching the mucosal barrier and going underneath. The epithelial cells of the gut mucosas respond to specific bacterial components by releasing chemicals that recruit immune cells. See, they particularly dendritic. Remember those ones with the fingers? Many of these are antigen-presenting cells, remember? Remember, macrophages, dendritic cells, and some B cells. The dendritic cells pry open the tight junctions between the epithelial cells and send extensions into the lumen. So they send their little processes in to check out the microbial antigen, see what's there. If they find something, they migrate to a nearby lymphoid and then turn on the T cells. Because remember, if these dendritic cells are antigen presenting, then what are they going to present to a T helper? IgA, immunoglobulin A, right, produced by B cells, right, in secretions. Okay, motility of large intestine. Haustral contractions, these haustral contractions, primarily due to the musculature, occur every 30 minutes or so. Slow segmented movements that occur mainly in the transverse and descending to move stuff along. They respond to having a distension there. They're trying to squeeze it through down here to defecate it. Slow moving but powerful contractions move over the large area. Okay. Some call this en masse movement. About 3 to 4 times a day, this whole intestine tries to clean itself. This whole large intestine. Typically, they occur after eating. It's what we call the gastrocolic reflex. So you may notice that when you start eating a meal, or shortly after, you may want to go to the restroom and have a bowel movement, because it's trying to clear out to bring new in. Of the 500 cc's entering the cecum, only about 150 becomes feces. So you reabsorb most of the water and the electrolytes back. Okay. Gastrocolic reflex. Presence of food in the stomach, as we talked about. Defecation. Okay. Defecation. Mass moves for its feces into the rectum. Distension initiates the spinal defecation reflex. Parasympathetic fibers do it, and conscious control. So, in other words, it's really kind of like urination in a way. You send a signal to the sacral area of the cord. Okay, that says it's something there. You want to defecate. The parasympathetic fibers, remember they come from craniosacral. The sacral parasympathetic fibers start contracting this, and they start opening the internal anal sphincter. But you keep the external contracted until you want to, because it's coming from the cortex. That's your conscious control. And bottom line, what you really are doing is maintaining what we call continence, and you can read on that. But it's really very much like what you had with the urinary system. So really nothing earth-shattering there. All right, so now we're going to start on a whole different series, and now we're going to talk about digestion. We've been talking about all these enzymes and this and that. Now we're going to finally put the story together on that.